So go ahead and try this problem. See if you can't figure out sine of 75 degrees times sine of 15 degrees. Okay, so for this one, we have sine of x times sine of y matches up with sine of 75 times sine of 15. So our x is 75, our y is 15, which gives us cosine of x minus y is 75 degrees minus 15 degrees, minus cosine of x plus y is 75 degrees plus 15 degrees, all over 2. So simplifying this, cosine of 75 minus 15 gives us cosine of 60 degrees, minus cosine of 75 plus 15 gives us 90 degrees, all over 2. Cosine of 60 is 1/2, minus cosine of 90 is 0. That's all over 2. So that gives us 1/2 divided by 2. And to simplify this, we can put this 2 over 1, which has us now dividing a fraction by another fraction. And remember, whenever you're dividing two fractions, you copy the first one, the 1/2, and instead of dividing, you change it to multiplying by the reciprocal of the second one. So we get 1/2 times, instead of 2 over 1, 1 over 2. So we get 1 times 1 is 1, over 2 times 2 is 4. So sine of 75 degrees times sine of 15 degrees is 1/4. Continuing from here, we now have the half angle identities, which are a bit more common than the product identities when you're dealing with trigonometry. And we have a lot of formulas here. We'll just go ahead and read through these really quickly. We have cosine of theta divided by 2, thus the half angle identity, is equal to plus or minus the square root of 1 plus cosine theta all over 2. Sine of theta over 2 is almost the exact same thing, except it's subtraction instead of addition inside of the square root. And tangent has 3 different formulas. You can use any of them. Typically the 4th and 5th formulas will be the easier ones to deal with because they don't have a plus or minus, which means you don't have to figure out which value to pick, the positive or negative one. But the nice thing about the 3rd formula is it doesn't rely on sine. It only relies on cosine of theta. So if you're only given cosine and not sine, then you can just use the 3rd formula. So with that, let's go ahead and find sine of 15 degrees. And the trick to this is just like when we had these problems in the past with the sum and difference formulas, when we would want to find sine of 15 degrees, we would rewrite this as sine of 45 minus 30, for instance. Well, now we need to rewrite this as a half angle identity. So how could we rewrite sine of 15 degrees as sine of something over 2? Meaning this. What would be equal to sine of 15 degrees that we could write as sine of something over 2? Well, that would be sine of 30 degrees over 2. And now that we have this, we can use our formula. We get plus or minus the square root of 1 minus cosine of theta, but theta is not 15, it's this 30, because remember, theta is divided by 2 inside of our sine function. So 1 minus cosine of 30 degrees all over 2. And now we start simplifying. The first thing to note is that it's sine of 15 degrees. Because it's 15 degrees, that's in quadrant 1. So because it's in quadrant 1, we want the positive answer, not the negative one. Because sine is positive in quadrant 1. So we get the square root of 1 minus cosine of 30 degrees is the square root of 3 over 2. And this is all over 2. And now the last thing that we want to do here is get rid of the fraction inside of the fraction. So to do that, we're just going to multiply the numerator and denominator by 2, which gives us 2 when we distribute, minus the square root of 3 over 2 times 2 will just be the square root of 3, and that's all over 2 times 2, which is 4. This looks pretty messy based on the fact that we have a square root inside of a square root, and this is honestly a good reason why the sum and difference identities would be a lot nicer for solving this problem, sine of 15 degrees. But for the sake of this problem, we now have the exact value of sine of 15 degrees using the half angle identities. And they do have their purposes, especially in problems like verifying identities. Okay, continuing on from here, we now want to go ahead and simplify sine of 8 alpha over 1 plus cosine of 8 alpha. Okay, so to go about this, we need to figure out which of our half angle identities matches this problem the most, if any of them. And notice, in terms of our half angle identities, it looks very similar to the second tangent function. So notice here we have sine of theta over 1 plus cosine theta, and in our problem we have sine of some angle over 1 plus cosine of some angle. So if we wanted to set this equal to tangent of theta over 2, then how would we go about this? So if we said tangent of theta over 2 equals sine of 8 alpha over 1 plus cosine of 8 alpha, then notice our formula says whatever is plugged into sine and cosine is the value that goes in for theta divided by 2. So in other words, going back to this problem, theta must equal 8 alpha. Because of our half angle formula, whatever's plugged into sine and cosine must be what's above the 2 inside of our tangent function. So with that in mind, sine of 8 alpha divided by 1 plus cosine of 8 alpha must be equal to tangent of 8 alpha over 2, which means it's equal to tangent of 4 alpha. So this is really a quadruple identity for tangent. Tangent of 4 alpha is equal to sine of 8 alpha over 1 plus cosine of 8 alpha. All right, continuing on from here, we now are given cosine of theta equals 2/3. Theta is greater than or equal to 3 pi over 2 and less than or equal to 2 pi. With that, we want to find sine of theta divided by 2. So the first thing we should note here is our formula for sine of theta divided by 2. Sine of theta divided by 2 is equal to plus or minus the square root of 1 minus cosine of theta all over 2. We should quickly decide whether we want the positive or negative answer if we can. And in this case, because theta is going to be in quadrant 4, then sine of theta divided by 2, we can quickly find that by dividing each angle by 2. And when we do this, we get that theta has to be less than or equal to pi, but greater than or equal to 3 pi over 2. That is, theta over 2 is in that range. Sorry, I made a typo here. Let me fix this. 3 pi over 4, sorry. So 3 pi over 2 divided by 2 would give us 3 pi over 4, and that's our range for theta over 2. So because we're finding sine of theta over 2, we need to know what quadrant theta over 2 is in. That will tell us whether sine is positive or negative. So it's not based on theta, but based on theta over 2. So because theta over 2 is between 3 pi over 4 and pi, that means it's in quadrant 2, which means sine is positive. We do not want the negative answer. Okay, so continuing on from here, we get sine of theta over 2 is equal to the positive square root of 1 minus cosine of theta, we know is 2/3. And that's all over 2. So we can start simplifying from here. 1 minus 2/3 we can rewrite as 3 over 3 minus 2/3 all over 2. Remember, 1 is the same thing as any number over itself. From here, 3 minus 2 gives us 1 over 3 all over 2. And finally, dividing by 2 is the same thing as multiplying by 1/2. So we get the square root of 1/6. And now we can just quickly rationalize. The square root of 1/6 is the same thing as the square root of 1 over the square root of 6. The square root of 1 is just 1 over the square root of 6. And multiplying the numerator and denominator by the square root of 6 gives us sine of theta over 2 is equal to the square root of 6 divided by 6.